Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 12. This is Section 15.2, Problem number 12. We want to find the integral of 2x e to the x squared plus 8 dx. Now, this is kind of a messy looking integral. It's not something that we'd be able to solve without the substitution method. Sometimes I say you could solve it either way. There's just more foiling or whatever if you solve it without the substitution method. This one you just need the substitution method. So the first thing I'm going to do is choose a value for u. There's only one choice that really fits. Again, what are our standard options? The stuff in parentheses. This problem has no parentheses, so that option doesn't fit. Stuff under the root, this problem has no root. That option doesn't fit. Stuff in the denominator, this problem has no denominator. That option also does not fit. Power of e, I do have a power of e. X squared plus 8 is the power of e. So that has to be the value for u. It's the only option that fits. So now that I've chosen u, the next thing I do is I find the derivative of u, which I write du. The x squared has a derivative of 2x to the first, and again, that's coming from the exponent of 2 coming down times the number in front, which isn't written but understood to be 1. 2 times 1 is 2. X to 1 less power, the second power drops down to a first power. The plus 8 on the end, because it has no variable with it, its derivative is 0. It's 2x plus 0, just 2x. And at the end, you put dx for derivative with respect to x. Now, what I want to do next is rewrite this integral in terms of only my new variable. Well, when I do that, let me just slide the 2x back next to the dx, and it'll make the matchup a little bit more clear. So I'm going to write the e to the x squared plus 8 first, and then that's going to be times 2x dx. And I can do that because the problem, the parts are being multiplied together, so it doesn't matter what order you multiply the parts in. I can put the 2x in front if I want, or I can put the 2x at the end if I want, whichever one I like. So at the end, it's going to be an easier matchup to see how it matches for the du. That's why I'm pulling it back. Now, what I just wrote is still written in terms of the original variable, the x. Let me rewrite it in terms of u. So e to the x squared plus 8 exponent becomes e to the u. And then I have to replace 2x dx. And I have a perfect match for 2x dx. It's equal to du. So solving the original integral is the same as solving the integral e to the u du. E to the u is the easiest integral to solve. It's just e to the u, plus some constant, of course. And you don't want to leave it with a new variable. You have to put the answer back in terms of the original variable, the x. So the answer is e to the u can be replaced with x squared plus 8, and of course, plus some constant.